through the basic introduction into properties of exponents. Most of this will be a review from 7th grade, so I'll go rather quickly through this. I'm unable to rotate the notes, so I think you can follow along the way that it's presented right here. So I'm going to give the generic, well, first of all, before I do that, I'm going to go to the second page just to make sure we have common language. The b in this expression represents the base, the n is the power or the exponent, and it tells you how many times to multiply the base times itself. And I'll come back to this page in a minute. So now going back to the cover sheet, just to do a few of these, I'm going to write this property in a generic definition form. When the bases are the same, you add the powers or add the exponents together. So I'm going to write the base one time, and I'm going to add the two powers together. So that would be a generic definition form for this particular property. I'm going to move down to another property that I think you studied in 7th grade, the same base quotient or the fraction. I write the base one time, and then the way that I handle the exponents, it's m minus n, or you might think of this as the top power minus the bottom power. M is on top and n is the bottom power. So the top power minus the power on the bottom. And that's just an easy way to remember that particular property. Okay, moving on down. Anytime you raise a base to the power of 0, that's equivalent to positive 1. So anything raised to the power of 0 is positive 1, and a base raised to the power of 1 is just simply that base itself. So a to the first is equal to just the base of a. And I believe you did negative exponents in 7th grade as well. So a mathematical way for stating how you write this so that the exponent is positive, you write the reciprocal of the base, and then the exponent becomes positive. Or an easy way to think of it is just simply place that base on the other side of the fraction bar, and then that exponent becomes positive. So here I've got a over 1 to the power of negative n. I would write that as 1 over a, and then the n becomes positive. And then the flip side of that is if the exponent is negative in the denominator of a fraction, the way that I would make that positive is writing this as a over 1, or just simply a, and then the n would become positive. So it's just a way to rewrite this so that the exponent becomes positive. The 2 in the 2 red 8s are for 8th grade, so I'm going to look through the notes for a minute and just review these properties, and then we'll come back and catch the other 2 in a minute. So I'm going to move back to page number 2 now. Just want to make a little basic observation here. I'm looking at number 1 and number 2. Notice I've got 4 x's. In number 1, they're connected by addition, and in number 2, they're connected by multiplication. So the way that I would simplify this expression, I would write that x one time, but this is really 4 times x, or just 4x. Whereas number 2, writing the base of x once, the 4 now becomes the power or the exponent. And it's all related to, or all dependent upon, the operation that connects the 4 x's together. The next topic to look at on the video is raising to odd even powers with parentheses, without parentheses, and negative bases. So when I look at an expression like number 3, notice that the negative 2 is encased in parentheses. So this is really telling me to take negative 2 and multiply it times itself 3 times. So here, that negative sign is affecting, or the power rather, is acting on the negative sign as well. So this is going to result in negative 8. When I look at number 4, I no longer have the grouping symbols, but I've got the negative base. So here, that negative sign is just sitting here. I can think of that negative sign even as a negative 1. And now I'm going to take the 2 and cube it. So this is actually going to result in negative 8. Here, the odd power of 3 is not affecting that negative sign, but the outcome is still negative. So I'm really just simply applying the 3 to the 2, but the negative sign without the parentheses tells me that I'm going to take whatever result I get, and I'm going to give that opposite outcome. So I have negative 8 for both of these, but for 2 different reasons. Moving on to the even powers, analyzing this. So once again, the -2 is encased in parentheses. So here, the base of 4, the even number, is acting on that negative sign. When you have a negative base multiplied times itself an even number of times, that negative sign becomes positive. So this results in positive 16. Whereas in number 6, I would think of this almost as two separate expressions. Here I have 16, but the negative sign is going to remain in the problem because the negative sign is not affected by that even power. That even power is only working on the base of 2. So here I've got the positive outcome and the negative outcome, and it's easier to see why that happens. I'll let you do that second row on your own, and I'm going to make an analogy here with numbers 11 and 12. So here I'm looking at negative bases with parentheses and an odd power. This is going to result in a negative number. Inside the parentheses, I've got the negative sign, the power is odd, that results in a negative number. And then the flip scenario would be same thing, negative base inside parentheses, but now my power is even. This is going to result in a positive number. The result would be a positive outcome. And then to talk about the origin of squared and cubed, if you're representing the area of the square, it's base times base, or b squared. So the reason why anything raised to the power of 2 is called squared is based on the area of the square. And then volume adding a dimension, base times base times base. This results in b raised to the power of 3, which is originated from the cube, and that's why when something is raised to the power of 3, it's sometimes called cubed. 3 cubed, x cubed, y cubed. That's the origin of the two expressions. Let's look at a monomial, vocabulary word. I want you to jot down this definition. The prefix mono means 1. So this is just simply a number, a variable, or the product of a number and a variable. I've given you a few little examples here if you want to stop the video and write this down. When you're adding monomials, same variables and exponents, they're considered like terms. When you're adding like terms, you just add the coefficient and the variable exponent arrangement does not change. So I did a few of these here for you already, just recognizing the like terms. Number 5 is already, number 5 I can do, but it was already simplified. I would add the 2 and the 9. Oh no, it's not. They are not like terms. So this will already be, they are prime to each other, or it's already simplified. You can't do anything with that. You would just leave that as it is. And I've done a few of these for you. I feel like this is a topic that you learned in 7th grade. Looking at number 12 very carefully, notice that the like terms are here, and that would be 9, and then you would just simply copy the other one. So just be careful with the variables. Just look at it closely. 13 through 16, the wording is a bit weird, and I went ahead and set one up for you so you can take that from there on your own without me. And let's start with a 7th grade skill. When the bases are the same, you add the exponents. So here's your definition. There's your generic definition. Looking at number 19, 7 plus 4. Write the base of W once, 7 plus 4. So this simplified expression, W would appear once, the power is 11. When it starts to layer up a bit, multiply the numbers, multiply the coefficients, write the base once, and add the powers together. Number 23, multiply the coefficients. Each base appears one time. Add the powers together for your simplified expression. Number 27, and that would be a -6, and I've got A and B. A is going to appear 7 times, and B appears 3 times. I feel confident that you can do these without my guidance, and this is the last thing that I'll do on the video, on this particular video. So here in 35 through 38, you are creating like terms which you're then going to add together. So I'll do 35, multiply the coefficients together, write each variable one time, and writing each variable once, adding the powers together, you've created a pair of like terms. When you create the like terms, simply add the coefficients together. So this written in its most simplified form as one expression looks like this. And I think I may stop this video here and move to the next. I feel like I have confidence in you all with your ability to do all of this without me. I'm going to stop this video here, and in the next video I'm going to catch this topic.